Theoretical recap. An Ethernet frame is a structured unit of data that operates at layer 2, data link, of the OSI model. It carries a payload from one MAC address to another within the same network segment. A standard Ethernet frame contains the following fields in order: preamble, 7 bytes, plus start frame delimiter, 1 byte, destination MAC address, 6 bytes, source MAC address, 6 bytes, ether type or length field, 2 bytes, payload/data, 46 to 1500 bytes, and FCS, frame check sequence, 4 bytes, a CRC checksum. Each field has a precise role. The FCS is calculated by the sender and recalculated by the receiver. Any mismatch signals a corrupted frame. Common mistakes beginners make include confusing MAC and IP addresses, misreading hexadecimal values, overlooking byte order, big endian, and ignoring minimum payload size constraints. Padding is added if the payload is smaller than 46 bytes. A useful mental model. Think of a frame as a physical envelope. It has a sender address, a recipient address, contents, and a tamper seal, FCS. If the seal does not match the contents, the envelope has been altered in transit. Understanding how to read and validate a frame is foundational for network analysis, traffic inspection, and later for tools like Wireshark used in penetration testing and forensic investigations. Workshop brief. This workshop places you in the role of a junior network analyst tasked with reviewing a series of raw Ethernet frames that have been flagged by an automated monitoring system. Your job is to examine each frame carefully, identify what is wrong with it, explain why it is an error, and determine what impact that error could have in a real network environment. This is a deliberate practice exercise. The frames provided below contain intentional errors of various types, and your analytical and reasoning skills are being assessed as much as your technical knowledge. You are given the following 5 raw Ethernet frames in hexadecimal notation. For each frame, you will need to break it down field by field, identify the anomaly or anomalies present, and provide a written explanation of your findings. Frame 1. FFFFFFFFFF 001A2B3C4D5E 0800 payload 30 bytes of data FCS A1 B2 C3 D4. Note: the FCS computed from the actual content would be 3F7E9A12. Frame 2. AABBCCDDEEFF AABBCCDDEEFF 0800 payload 1520 bytes of data FCS computed and valid. Frame 3. 001A2B3C4D5E 009FABDCC11 0800 payload 20 bytes of data, no padding added, FCS, computed and valid for unpadded frame. Frame 4. 001A2B3C4D5E 009FABDCC11 0000 payload 64 bytes of data, FCS, computed and valid. Frame 5. 001A2B3C4D5E 009FABDCCGG 0800 payload 100 bytes of data, FCS, computed and valid. Steps to follow. Begin by reviewing the structure of an Ethernet frame using your previous course materials. Make sure you have a clear reference for what each field should look like, its valid size, and its expected content. Do not rush this step. A solid reference model is what allows you to spot deviations. For each of the 5 frames, parse the hexadecimal data field by field. Write down what each section represents and what value it contains. Then, ask yourself, does this value make sense? Is it within the valid range? Does it respect the protocol specification? Document your observations for every field, even those that appear correct. This is part of the analytical discipline expected in security work. Once you have identified the error or errors in each frame, classify each one. Use the following categories as a guide. You may use your own taxonomy if you can justify it. FCS/integrity error, field size violation, invalid field value, protocol logic error, or addressing anomaly. For each error, write a short paragraph explaining what the error is, what rule it violates, how a network device, switch, NIC, router, would typically react to this frame, and what security or operational risk it could represent. Finally, write a short synthesis, 1 paragraph, around 150 words, summarizing the types of errors you found across all 5 frames, what patterns you notice, and how this kind of analysis connects to the work of a cybersecurity specialist, particularly in the context of traffic capture and anomaly detection with tools like Wireshark. Advice and tips. If you are struggling to decode the hexadecimal fields, use an online hex to decimal or hex to ASCII converter. Tools like CyberSecurity gchq.github.io/cyberchef, are very useful for this. If you are unsure about valid ether type values, the IEEE registry is publicly available. Pay special attention to frame 5, hexadecimal notation has a defined character set, and anything outside it is immediately suspicious. For frame 2, think carefully about what the source and destination MAC addresses imply and whether that is logically consistent. For frames 3 and 4, revisit the minimum and maximum payload size rules from your Layer 2 course. Do not overthink the FCS. For this exercise, you are told explicitly when it matches or does not match. Your job is to explain the consequence, not to recompute it manually.